So I will now go back to the GitHub page and start talking about it from here. Now you will see there are two basically tutorials for NuSTAR. So this is the tutorial that you will, like the similar tutorial that you will find online in the cookbook for NuSTAR. It's like extracting the science products for NuSTAR is pretty straightforward. It's doing very similar to RxTE. And as I mentioned yesterday, it's basically a combination of what you've done for XMM Newton and RxTE, so that you have to still need to define your source and background regions, and you have to be careful with it. And it is not going to be modeled separately as long as you're not working with extended sources in which your background is going to be much, much different than just a specific patch in the sky. And then you will see that there are a couple of scripts that you will be running just to get the products, and you do not have to do anything manually after that point. This one specifically is a very simplified version of a notebook that is developed by, again, Carlo Ferrigno. I list all of these things here because these are also is needed for NuSTAR pipeline module as well. So it's better to not start removing some of these things. So you will see that it's basically Python wrap for this, just extracting your science products. If anyone is interested in, I can give you a more extended version of it. It does seem like it's more complicated than let's say the traditional methods within Airsoft, but it gives you a little bit more freedom in terms of what you want to do with your data. You can take a look at it. If there's anything that you don't know what it means, please ask me, or you can directly ask actually Carlo. But I will start from NuSTAR. So NuSTAR is actually one of the very important observatories that was ever developed to observe the high energy patch of the sky. Similar to our XTE, it only goes down to 2 to 3 keV. So you unfortunately are going to be missing quite a big chunk of information that you also miss from our XTE. But studying the accretion disks itself has never been the main focus of NuSTAR and its development. So it's mainly to study the high energy parts of the sky. One very nice feature of NuSTAR is that no matter what you're working with, you do not need to worry about pile-up issues. So you can easily ignore this. That was not an issue for RxTE as well, because it's not an imaging instrument, but NuSTAR is. So it will have two focal planes, FPM-A and FPM-B. So focal plane A and focal plane B. And it will go up to 79 keV. So it's a lot more extensive than RxTE. I mean, as you've also seen with RxTE, that you can actually, if you have a very high energy event happening in your source, then you can actually increase your energy range, because then you would not need to worry about background. It will be very similar for NuSTAR as well. So if you also have a very soft source that you don't have too much of a contribution from power law or any other processes that might contribute to your high energy tail, then you might want to restrict your energy range to avoid background contamination. So for this one specific, there will be only 2 steps that you will run. They will take quite a long time, even longer than just downloading the data. So you would need to run new pipeline first to produce your stage 1 and stage 2 products. This is just done very simply like this. What you would need to do is that you need to run your command from the directory that you have your observation directory in. So you will be working on top level, and then you would say your input directory is this one, and then you will define your output directory as this. And then what you're gonna do is to actually try and look at your cleaned event file that will be produced by running NuPipeline. So you will be looking at event files like this. So technically, if you're working with an imaging instrument, you do not have to like you can easily just open your cleaned event files with DS9. You will see pretty much the same thing. What we did with XMM Newton is that we defined specifically certain coordinate systems to display the spatial information. With NuSTAR, you don't really have to deal with that in a similar sense. So you can just easily open your cleaned events in your DS9, and you will look at most of the times it will be just one source in the field of view, and you will see an empty or empty-ish space around it. So for NuSTAR, the point spread function, which tells you how well your pixels are going to be distributed along what you see from your observation, it's quite worse than XMM Newton. So it's better to actually include as large of a region for your source as possible. So and also it will also mean that, okay, you can actually go to like a smaller radius over here, but it's much better to actually include this one because due to the function's definition, that you would still see these photons actually going to be detected from the smaller region that you see. So what you need to do is that you will have your background region somewhere again from a source-free region nearby the source, and it will be a little bit bigger so that you get as many counts as possible to model the background that you will be getting from the outskirts of your source. Be careful, you will need to check these source regions in terms of coordinates for the focal plane A and B separately. You will also need to save these regions separately for your A and B focal planes. So in DS9, if you remember that there was this region tab, and once you are done with your source selection, please do not save them all together. Like if you plot them all together and hit save, it will save both regions at the same time. So be careful. Do not start by choosing background at the same time. This is just for to be able to show you what it should look like. Once you define your region separately, you click on save. It will prompt you to choose a directory, put it somewhere over here where you define your working directory so that it can actually access these regions. Or you can alternatively, if you want to put them somewhere else, you can define the path when you define it here. Save the names as they are here, because if you want to try out the NuSTAR pipeline module that I showed you, it will look for a naming system like this to be able to identify the source regions. Unfortunately, it's not defined, it's not user defined as it is right now. Hopefully in the future it might be a little bit different. Here is going to be how you run new products to actually produce your light curve and your spectrum. Once you start running these things, you will see that it will open and it will start running different scripts that will be doing exactly the same in the case of XMM Newton. So it will be applying the same corrections in the same way, but only within one command line that you do not have to do anything else. you need to be changing the instrument here for each instrument. Since you will have two different source regions, source A and source B, you have to run it separately, in contrast to the case of new pipeline. You can basically just run it this way, and it will do it for both focal planes. But if you want to run it for just one of them, you can add this in the end. Also, as I said, this is stage 1 and stage 2. The script will only run it until the stage 2. But if you wanna just stop for calibration or apply a different calibration method, you can add this to your to the end of your comment, and then it will end before, like, it will just end at stage 1 level. And so as you remember from both, I mean, we didn't run this command for XMM Newton because it's done in one comment. It was the spec group comments that you apply your grouping for the spectrum. So here you can actually run this FTools tool grouper within one command line. You can basically add it to the end. It will just run it. It will group your spectrum for minimum count rates of 30. You can change this. And it will also define bad channels. So it will say channels below 35 and channels above 1909 will be considered as bad. So similar to the ignore comments that we had yesterday, we only excluded certain energy ranges. But if your instrument also is known to have some bad channels, for example, certain channels will lose sensitivity to the energies that you have in your instrument over time. And sometimes some of them will be labeled as bad. So you can also run ignore bad, and then it will exclude these. For NuSTAR, if you define it this way, ignore bad will remove anything below 3 and anything above 78 keV. So this is basically just a bit of a help. So to include all of these steps, you will be running this final command line, and this will give you your grouped spectrum for your focal plane A, and you will run it for focal plane B separately as well. I am now realizing that I did not add the new pipeline over here in the beginning. So if you want to run it now, you can basically add it here, but I was also corrected on the tutorials. Do you have any questions?
Not right now, thank you.
So if you want to start running it, as I mentioned, it will take quite a lot of time. I will also be running it alongside of you. So I will also give you some how's it called, directions to define your source region. So I will give you some examples for coordinates and how large the area should be. Ideally, as I mentioned on Monday, I believe, when you start reducing data that has been published already, you can just easily go and check the published papers. Maybe I can show you actually how to do it. So I have the NuSTAR. No, this is XMM Newton for a ULX that I'm working with. If you look at the services column over here, you will see a tab called B. It will give you the bibliography for that specific observation, which it will tell you what papers have been published. So currently it only gives you one paper, but normally it can give you basically a list of papers that that will go like this, so you can easily go and check what those papers have done and basically start applying their like source selection regions and stuff. So you can start working on it, and we can actually get back to source selection region once you already have your clean events. Is that all right?
Yes, but I must tell you that I was able to remove my folder. I don't know how. So I'm downloading it kind of again.
Oh, perfect.
Unless someone can send me this folder, so I will
Well,
need
I
to
am.
download it. So it will take some time.
Yeah, no
So,
problem. Today's gonna be a bit of a long pause day,
yeah,
so you don't need to record everything in between.
yeah, I will probably pause it there so they can see that we are doing something. Okay, so you should be seeing my screen.
Yes.
Okay, just a moment because okay, Deborah is writing something, so it's checking. Uh, okay, so I will just do this to be sure that I don't have to put E, and then I want to probably. Okay, I did something bad because I'm not in the folder. I need to be in the folder. So again,
Mm-hmm.
um, data, and I want the group one, right?
Mm-hmm.
Yep. Yep. Okay. Um, eh, sure. Just put it down. Okay. So this is. Do you see it?
Yeah, yeah. So you now are seeing a block of
Yeah.
so it means your energy bins above I think that
20,
corresponds to
30,
approximately
40,
80. So
78, 80, I know.
yeah, so that's the part that the instrument is not sensitive to. That's why you define certain energy channels as bad channels. So
Yeah,
anything
in
above,
the group, the
yeah. So
group. Yeah.
on your terminal, if you type ignore bad, you see that there are tons of channels have been ignored,
Yep.
and that corresponds to exactly that region.
Oh, nice.
Apart from flagging these bad channels, you will also have, for NuSTAR specifically, that you will have some other channels that might have, let's say, some sensitivity issues, or something might have happened during the observation due to the high energy events happening in the source. Some of those other channels might be also bad, might be flagged by bad during the extraction of the products.
Yeah.
Uh, and they would actually affect the statistics of your fit. So if you want to check for this one, if it actually happens to be there, if you don't want to use ignore bad, and if you just want to use specific energy ranges, that's fine. But you will see a certain warning pop out, and it will say that the reduced chi-square statistics cannot be used for your data set if that's the case.
Yeah. Mm-hmm.
You can test this by loading your data right now again, and then define a very simple model, and you will see the warning, hopefully. But it always happens that way with me, at least. You can test it by reloading your grouped spectrum.
Okay, so just data again?
Yeah.
Or... Okay.
Yeah, okay, now define a model, like just say this PB, let's say. And just keep hitting enter.
Yeah.
So you see the warning. So chi-square may not be valid due to bins with zero variance in spectrum numbers 1. It means that there are some certain spectral bins in your whole energy spectrum that basically have zero counts.
Mm-hmm.
Which you've already seen in your spectrum when you plot it. Although the error bars are super large, so it doesn't really show like you actually have zero counts. So you need to ignore those energy bins, but this will not be only specific to high and low tails of your spectrum. There could be other bins throughout your spectrum that will be behaving the same way. So it's always better with, especially with NuSTAR, to ignore the bad channels that are flagged while you extract your spectrum. So if you say ignore bad again, you can see that your fit statistics chi-squared now has a different number.
Yeah.
If you start the fit, you will see that your warning is gone. The fit is pretty bad because there are certain things in the spectrum that you are not accounting for. But again, the warning is gone. Now you can use your chi-squared statistics.
Okay.
So that's pretty much it for extracting the spectrum with NuSTAR. For you can try doing it with the NuSTAR pipeline module. I know you said you didn't like Jupyter notebooks, but you can create a full script out of it by yourself and see if you can actually make it work.
Okay, but I need to find it here. Oh no, you have it somewhere in the GitHub, right?
Yeah, it's on GitHub.
Yeah, NuSTAR pipeline. Yeah, I can see it. Yeah.
So it's currently 11:22. So if you can send us the spectra, because for me it's gonna take quite a while to
Yeah, I
it.
was just doing this for Martin, but you know what? I will just wait a moment. I will post it to the general. This
Yes.
should be a link for the products B and A that you should download it.
So
Just tell me if it works because I'm in you're in Prague, so it should work. Because I know that in some countries in Europe it doesn't work. So I was...
I mean, we're in the same country.
Yeah, it's just, I I remembered that quite later after I started talking. So
It seems to be working for me right now.
yeah, it's like 52 megabytes. It's not really big, so
Yeah. When you extract the data from NuSTAR, you download 8 gigabytes and then it keeps producing new products. And what you end up with is like 50
yeah,
megabytes.
one folder is 25 megabytes. Yeah, it's like
Yeah, it's a very ironic situation.
yeah. I
So
can
for me, it
download.
seems to be downloading like okay.
I think you should be able to have it in a few minutes. I don't know how your connection is, but
no, it already downloaded.
yeah.
So since now it's near the end of the first morning session, I suggest that we keep producing the spectra as we are doing for Martinez, at least to see if there are any errors along the way, or if there's anything that you need to deal with. And if it does not finish running until the afternoon session, we can basically use Tomasz, the products that Tomasz extracted, and we can start analyzing the spectra at 2 p.m. if there's nothing else you need to be doing at that time.
Okay.
It works for me. Perfect.
Yeah.
Yeah.
All right, then we'll see each other at 2 again.
Okay.
By the way, I got the FPMA.
Oh, okay, it worked,
How
right?
it went through. So I guess this, and it was much quicker. So I guess it was because the connection was slowed by this upload audits.
Yeah,
Yeah,
possibly.
maybe.
Pretty possible, yeah. So that's perfect. Then you can, if you have the time, during the break, you can start working with the products, the
Yeah.
science products. And I mean, we currently have I didn't open the. So it also has the GIFs created from your spectrum and your light curve. And if you want to take a look at the light curve, very quickly from the files that Tomasz sent, I will quickly share actually a screen and tell you what I want to show you. So here is a GIF from the light curve. This is the thing that I was talking about for GRS 1915, that in the light curve, there's a very nice short-time variability. And this is the thing that people usually want to investigate. Like you can see that it's actually, it looks like it's pulsating. So instead of having the general variability that you would normally expect from black hole X-ray binaries throughout the outburst, you can even see and observe these things within one observation of GRS 1915, and you can see that it's not really even that long of an observation for like the general time frame. At least let me see if it actually has any other thing. No. On top of that, you can also see what your spectrum looks like after the back channels are ignored. And there are other stuff like the image that is also being produced.
What is the movie? I never understand the movie.
Yeah, I don't know exactly what it is, and it cannot be opened.
Yeah, because it's the .lfc. I don't know. I couldn't find
Looks like I
anything
can
to
open
open
it
with.
with Skype.
You can try. Maybe it will call someone to tell us.
Yeah, I don't want to expose my Skype chat history right now. But you can see here the image, which is pretty nice. Oh, of course, the scale and the color is very different, but you can see like the like where it lies on the coordinate system and everything. It's pretty nice.
Yeah.
So yeah, these are basically the products that are produced from your new products running procedure. So it's always better to check these light curves and everything. So normally what you would do is to extract everything by yourself. It was done that way when I was doing my bachelor's, and now I just sit back and it does for me, which is amazing. Otherwise, you would need to, you probably saw from your terminal output that it actually goes into X select,
Yeah.
and it does all of the region selections and everything by itself. You might want to practice with it a little bit to see what you can do, because I believe no, there's also another instrument, NuSTAR, that does a similar that has a similar approach, and it used to go through the X select again, but it also has to like very recently transferred into just a couple of lines of comments to run the entire analysis. By the way, I will also include these tutorials on GitHub as well. So like how to produce nicer data, Chandra data. So this will be like a full selection of current X-ray observatories at least. And if you want me to, include anything else, please let me know. Including all of these tutorials has been like a project at the back of my mind for a very long time. So it will help me to, guide a lot of people throughout the process in the future.